All right, so we're on lesson 4, solving systems by graphing. First of all, what is a system of equations? We didn't get them. So a system of equations is nothing more than two or more equations that are linked together through braces. So it'd be something like this. Y is equal to 3x minus 4. And it could be something like 3x plus 4y is equal to 10. See, there's two equations that are linked together with braces. Now, when we solve systems of equations, here's the goal. Y'all ready? It's to find the value of x and y that makes this equation true, and that exact same value of x and y has got to make this equation true. And I'm going to show you many ways of doing this year. The number one way that I'm going to show you today to do this is through graphing. All right, we can also solve systems of equations with a technique called substitution, and we're going to learn that probably in a couple days. And the number 3 way I'm going to show you how to solve this in Algebra 1 is through elimination. Now when you get to Algebra 2, we'll use Gaussian elimination to solve these. We'll use matrices to solve these as well. Okay? So there's a lot of different ways of solving these, but right now I'm just going to teach you these 3 ways, and way number 1 today is through graphing. So what's the application of this? Are you ever just going to see a problem like this on the ESC and it says solve it? Absolutely. And that's exactly what the problem would look like. It'll just say, hey, y'all solve this. Okay? So how do you do it? Well, you're going to pick one of these 3 methods and solve it. I don't care which method you choose whenever you take the EOC, but you got to know one of them. Okay? But in this class, you got to know all 3. Okay? So let me show you an application, because they're not just going to have it like this. Here's an application problem. Okay? Just to show you what it's going to look like. Let's say I've got some coins in my pocket, and I know I have dimes and quarters in my pocket. All right. I remember I had a total of 9 of them. Okay? So I had 9 total coins. Right? And I know also that the value is $1.35. Because I remember seeing that in my hand. I saw 9 coins, and the lady said, after I bought some bubble gum or something, that here's $1.35 and change. And I remember that because she said, I'm sorry, I don't have any dollar bills. So how many quarters and how many nickels do you have? See, this is an application to a system of equations, because there's a lot of different variables in that problem, but ultimately, here's what I'm trying to figure out. I'm trying to figure out this system of equations. I know I have 9 total coins. Do you agree? And it's only a combination of dimes and quarters. So if I take the number of dimes that I have plus the number of quarters that I have a total of how many of these? 9. You follow? Likewise, I know that the value of these coins was $1.35. So if I take the value of my dimes plus the value of my quarters, I have $1.35 in my pocket. So what is the value of a dime? It's 10 cents per each one. So if I had 1 dime, it would be what? 10 cents. What if I had 2? It's 20 cents. What if I had 3? 30 cents and so forth. So this is really 0.1 times the number of dimes that I have. And when I put a number in front of a letter, it means multiplication. Plus the value of my quarters is what? 25 cents for each one. This is what you must do on the EOC. You're going to be given a word problem. You've got to come up with the equation for it and then solve it. Like I said before, if you see these on there, it might be 1. But these right here, there's at least 2 to 3. So you got to be able to use your technology to solve this, but you also got to use your brain to solve a word problem to set up this system of equations. Okay, so how are we going to learn how to solve this today? Well, you could just randomly guess and check, and I could have 0 dimes and 9 quarters, 1 dime and 8 quarter, 2 dimes and how many quarters? Okay, I could have 3 dimes and 4 dimes and 5, 5 dimes and 4 quarters to give me 9. 6 plus what is 9? 3 quarters. And I could randomly guess and check and plug it in here and plug it in here and make sure it makes both of them true. And we could do that, right? We could guess 2 dimes and 7 quarters because 2 plus 7 is 9. Do y'all agree? So this is guessing and check. Y'all already did this in 8th grade, by the way. Y'all solved it by guessing and checking in 8th grade. Y'all made a table. Right? So you should have already learned that. That should have already been tested on the EOC or the STAR test in 8th grade. So let's plug it in and see if it works here. So that would be 0.1 times 2, right? Because there's 2 dimes, which is 20 cents. Plus, if I have 7 quarters, what's 7 quarters times 25 cents? So I just take 7 times 0.25 and it'd be $1.75. Is that equal to $1.35? No, that's not going to work. Right? So that didn't work out. So I'd have to guess again and keep working until I get it to work out, because it'll eventually work out. Because I only have a finite number that I could guess. Okay? So I don't like that method. I need a systematic method. So guess what? I'm going to choose one of these 3 methods to solve this problem. And the way that we're going to learn today is by graphing. So how do I graph this and solve it? I have to be able to write these, not in terms of D and Q, but in terms of, how do we graph in our calculator? X's and Y's and Z's, right? So I got to figure out that X maybe is my number of, what would X be? Number of, what's it in this problem? Dimes. And then I'm going to make this quarter be, or Q be Y, so Y is equal to the number of what? Quarters, right? You understand? X is the number of dimes, Y is going to be the number of quarters. So instead of 0.1 times D, it's going to be 0.1 times X. Plus 0.25 times, not Q, but Q is what in my calculator? Y. Can't put D's and Q's in there. I can only graph in terms of X and Y, so I got to make one of them X, one of them Y. So really I'm solving this system of equations. What 2 numbers can I add together to give me 9? That when I multiply the first one by 0.1 plus the second one by 0.25, it gives me $1.35. That's the hard part. The easy part is solving it. Why is it so easy to solve this? Well, here's why it's so easy to solve it. I got technology. How do I graph this in standard form, and how do I graph this in standard form? They're basically in standard form, aren't they? How do I plug them in my calculator so I can graph it and see where they cross? Go to a new document. Don't save my last one. Add the graph. How do I graph this one? You might want to follow along. This is, if I graph it as function, I got to put it in slope-intercept form. So you got to put this in slope-intercept form if you do it this way. But what's a way I don't have to put it in slope-intercept form? That you should have used on the last test. Go to Menu, Graph Edit Entry, graph not a function but a relation. And type it in exactly how it's given to you. X plus Y equals what? 9. Enter. There's the graph of that one. Here, let's graph the next one. So go to Tab to graph another function on the same screen. Hit Tab. And graph the second relation. So you just type it in the exact same way it's given to you. So it's 0.1 times X plus 0.25 times what? Y equals, that's right under the control button, 1.35. Hit enter. There you go. What's my solution? Where are they the same? That intersection where they're the same is the solution. That's the value of the dimes and quarters for the red graph. That's equal to the dimes and the quarters from the blue graph. So how do I find where they cross? Go to Menu, Analyze the graph. Where 2 lines cross is called a intersection. Move it to the left, move it to the right. It's 6 and 3. What does that mean? They cross at the point 6, 3, but that's the coordinate X and that's the coordinate Y. What was X again? dimes. So this means I have 6 dimes and how many quarters? 3 quarters, because y is quarters. So when I answer my question, if it's relating to something in the real world, I do not leave it as an ordered pair. This is called an ordered pair. I don't leave it that way. I write it how it means in the problem. Does that work out? What's 6 plus 3? 6 dimes plus 3 quarters is 9 total coins, like it's supposed to be, so it makes the first equation true. And that exact same x, which is 6, so 0.1 times 6 plus that same y, which is 3, 0.25 times 3. When I take 1 dime, or 6 dimes times 10 cents each, that would be 60 cents plus, what's 25 cents times 3? 3 quarters is worth 75 cents. What's 60 cents plus 75 cents? $1.35. That same x and same y made the second equation true. Do you understand? And that's how difficult it is. You just got to be able to set up the equation in your technology. Alright, so what we're going to do now is we're going to look at some terminology, okay? Do you see our answer in that last problem that we just did? How many solutions did I have to this problem? There's only one answer, isn't there? That has a name, and this you must know. This is going to help you on your homework, and it's also going to help you on the next test. If it has one solution, it's easy to see that these lines intersect at one point, right? Okay. If you have lines that intersect at one point, that means there's one solution, but that has a name. The name for a system of equations that have one solution is called a consistent independent solution. Okay, let me explain that a little bit further. What does consistent mean? Consistent means at least one solution. Does this have at least one solution? Yes. Independent means that you stand alone, all by yourself, the one of you. So independent means all alone, right? All alone or just one. So that's why that's called an independent consistent system. Now, sometimes when we graph things, let me show you this, right? Let me go to a new document. Sometimes when we graph equations like this one, y'all ready? What if I had this system of equations? Y is equal to 2x plus 3. And then y is equal to 2x minus 2. What if I graph them and they have the same slopes? Are they ever going to cross? Are they ever going to share an x and a y point like this one does if they never cross? Then that means if they never cross, there's never a point that makes the first equation true. There's never a point that makes this blue equation true and this red equation true. They're not going to share a point. That means no solutions. And there's a word for that. If there's no solutions, they are not consistent. The prefix "in" means not. So this is called an inconsistent system. You got it? Now watch this. What if I change one of these equations? So I'm going to go over here and change this one to be an x instead of a minus 2. What if it's an x plus 3? What's this? Plus 3. And I graph it and they fall right on top of each other. See, y'all don't see this, but there's two equations right on top of each other. Watch, I'm going to move this second one. See my hand? So y'all take your cursor, move it up there. You see how the hand's open? I'm going to hold down the middle of my screen until my hand closes. Hold down the middle of your screen and it's going to close, and I'll move one of these down. You got two equations that are exactly the same, and they're two lines that fall right on top of each other. So how many points do they share? Every one of them. So if you have a line that you graph, and you graph another one, if it falls right on top of it, that means that they share every point. There's infinitely many solutions. So what is that called? Is it a consistent system? Does it have at least one solution? Yes. So this is called a consistent dependent system. What does dependent mean? you rely on many. Dependent means you're relying on somebody else for your own support, so it's more than one, so it's two or more. So if it's a dependent consistent system, it means it has many solutions, because dependent means that you rely on many. Like there's infinitely many solutions. Consistent means at least one. So this is consistent, but this one's dependent, this one is independent because there is only one point that they both share. Do we understand the definitions? Okay, so that's really all there is to this. So we're going to solve some systems of equations by graphing with pencil and paper and then checking it with technology. Because unfortunately we've got to be able to still know how to graph equations like this with pencil and paper on the EOC. So we're going to practice both. Solve that system of equations. So find the value of x and y that makes this one true and this one true now. So to do this, we're going to do it by graphing today. So how do I graph this first equation? Well, it's in slope-intercept form. Can you tell me the y-intercept? Where does this cross the y-axis? 2. So here's my y-axis. Here's my x-axis. It crosses at 2. What's the slope? 1. 1. There's a 1 in front of that. So 1 over 1 is the same thing as 1, is it not? And that's my rise over my run. So I'd have to rise up 1, run 1. Rise up 1, run 1. So we can make this graph very easily. Can y'all see this okay? So can you make your graph? Use your slope. And then now get your ruler. Or if you use a whole bunch of points, I think I can do this without a ruler. And that's the graph of what? The first one. How do I graph the second equation? Well, it has a y-intercept of -2. So I'll put a dot at -2 and then use my slope to find other points. What you working on there? You good? You already did this? So use my slope to find other points. Put that down. You got to be working on your homework check. So my slope is what? 3. Isn't 3 the same thing as 3 over 1? So that's my rise over my run. So what's my rise from there? Rise up 1, 2, 3, run to the right 1. Rise up 1, 2, 3, run to the right 1. Look, see how that's where they cross. I pretty much can stop because they're going to cross where? Right there. So that is a independent. Why is it independent? Because there's one solution. And it's what type of a system? Consistent. It's a consistent, independent system, which means that there's going to be one solution. What is that one solution? What is that ordered pair? Remember, these are ordered pairs. This is x is 0, x is 1, x is 2, x is 3, x is 4, and so forth. Like this is x is 1, x is 2, 3, 4, 5, and so forth. Where is that point right there? X is 1, 2. So that's at the ordered pair 2. And what's the y coordinate? 1, 2, 3, 4. 4. So how do I write that answer if it is not a word problem? Do I do it this way? X is 2, y is 4. Is that right? Sure, but you're not going to see it that way. On the EOC, they're going to write it as an ordered pair. 2, 4. That's it. So how do we check it to make sure it's right? Here's how to check it to make sure it's right. Look, if x is 2, plug that in there. See, x is 2 plus 2, which is equal to y. What's y? 4. Isn't 4 equal to 2 plus 2, which is 4? Yes. You see how it makes the first equation true? Everybody understand how it makes the first equation true? Does it make the second equation true? Plug it in and see. If x is 2, plug that into the second equation. So here's my second equation, 3x minus 2. If x is 2, this would be 3 times 2 minus 2. Is that equal to y, which is 4? True or false? 4. Is 4 equal to, what's 3 times 2? 6 minus 2. What's 6 minus 2? 4. 4 is equal to 4. So you see how it makes the second equation true as well? So I know we did it right. Now how else can I verify that we did it right? Why not just graph it in a calculator? See if that really is the intersection. So our calculator will do this for us as well. Watch. So cut it on. Go to your home screen. Go to New Document. Don't save my last one. Add what? A graph. Do I need to change this to a relation? No. It's already in slope-intercept form. This is y is equal to mx plus b. Y is equal to mx plus b. So this f of 1 of x means y is equal to. So I just type it in. Y is equal to x plus what? 2. Enter. Hit tab and graph the other one, which is 3x minus what? 2. Enter. Doesn't that look like our graph? How do I know where it crosses? Do I have to just look and go, I think it crosses at 1, 2, 1, 2. I think it crosses at 2, 3 or 2, 4. How do I know exactly where that point is? You know, your calculator will tell you that. So to do calculations in your calculator, hit the button Menu. Hit Menu, Reese. And then I go to what? Analyze Graph. Go to the Analyze the Graph, which is 6. And what do we want to find? Where these cross. What's another word where lines cross? It's called an intersection, which is 4. Now it says, all right, what do you want to find the intersection in between? So in between these two lines, I'm going to set 2 lines. I'm going to move this line to the left of where I think the intersection is. Hit Enter, or the middle of your screen, and then just move it to the right. So I want to find the intersection between those 2 lines. Hit Enter. And it did it for you. It's right there. Can you see it? I can't. It's a jumbled up mess. Even if I zoom in, it's still hard to see. So I'm going to take my little hand, put your little hand right on top of that ordered pair. It's about right there. Do you agree? Push the middle of your screen until the hand closes. Right there. So I got to hold it. Now I can move it and see it. Can y'all see it better now? And then let go. Push the middle of the screen to let go and move your cursor out of the way. There it is. It's at 2.4 just like this is at 2.4. I checked it. I know it's right. You know another way that you can check it? Call up the table. Sometimes on the EOC it's going to have you solve it by using a table, and it's just going to be a picture of a table. How do you know what this solution is by a table? Watch this. Call up your table. How do you bring a table up on this screen? Yeah, remember? Control T as in Tom. Control T. And here's a table. My solution was 2, 4. Let's see. Look. If x is 2 in the blue function, what was y? 4. If I click here to the right one time, in the red function, if x is 2, y is also 4. Do you see how they have the same y values? Left, right. I'm just moving it to the left and right. The blue function and the y function, the y values in both the red function and the blue function, f1 and f2, is equal to what? 4. Okay, I don't know what I just did. I accidentally cleared that out somehow. Okay, see if I can call it back. All right, let's remove table, and then see if I can call it back. Yep, there it is. Y'all see that? 2 and 4. So I promise you're going to see one like that on the EOC too. You will see one like that on the next test, where I'm just going to give you a table. I'm not going to give you a picture. I'm going to give you a table and say, from the table, where's the solution? I've seen that on a lot of EOCs as well. You get the idea? So y'all want to do this one with pencil and paper, and then we'll check it with the graph. That's it. So we're going to speed it up a little bit now that you understand it. Solve that system of equations. Find the value of x and y that makes the first one true and the second one true by graphing it. So look, we're going to graph it right here with pencil and paper first, because you've got to know how to do this. What did I just make? An x and a y ordered pair, or coordinate plane. Now this one's in slope-intercept form, so what's the y-intercept here? 4, so I'll put a dot at 1, 2, 3, 4. So this crosses the y-axis at 4, and use the slope, which is 2, to find other points. 2 is the same thing as 2 over 1, and that tells me my rise over my what? Run to find other points. So rise up 2, run to the right 1. Can't go anywhere else, right? I can try to guesstimate up 2, right 1, but I can find points to the left by going down 2, left 1, down 2, left 1, down 2, left 1. Right? You get it? So fill up your graph, or fill up your paper with points, and then let's play connect the dots with a solid line. And let's graph the second one. So what's my y-intercept there? 2. What's the slope? What's the number in front of the x here? It's a 1. That's the same thing as 1 over 1. So that's my rise over my what? Run. So if I find other points, I rise up 1, run 1. Rise up 1, run 1. Fill that up with points. Well, that's the same thing as down and left 1. Down 1, left 1. Down 1, left 1. So down 1, left 1. Down 1, left 1. Crosses right there. See how they share that same point? Where is that point? My solution would be x is negative 2, y is what? 0. Let's verify that with our calculator. How do I verify that with my calculator? Watch this. We're going to do something a little different this time. Y'all ready? Go to New Document, just like we have. Don't save your last one. Add a graph. Yes, we're going to do that the same way. But this time, I don't want to graph this, even though this is in slope-intercept form. I don't want to graph it in slope-intercept form. I want to graph it as a relation. Y'all know how to do that? So let's change how we're graphing things by going to Menu, and then Graph Edit Entry. So we don't want to enter it as a function. We want to enter it as a relation. And I'm going to show you, this will help you and hurt you at the same time. It helps you because whenever I graph it as a relation, I just type in whatever I'm given and it'll graph it. So I graph literally y equals, so I'll find the y button at the bottom of my screen, equals is below the control, and then 2, and then my x is down here, right, and then plus 4. And hit enter, and it will literally graph whatever you type. Okay? And then hit tab, and let's graph the second function, which is y equals x, what? Plus 2. Type it in exactly how you're given. That's cool because it'll even do it in standard form. It'll do it in point slope form. It'll do it in unsolved form. It'll graph anything you tell it to. It's pretty smart as a relation. Hit enter. And then find the intersection by going to Menu, Analyze Graph. What do I do now? Go to 4. Where do they cross, in other words, is the intersection. And then I move this to the left of where I think it crosses, hit enter. Move it to the right of where it crosses, hit enter. And there it is, negative 2, 0, just like we did. Now, what's the downside of doing this way? I said this is going to help you and hurt you. Here's the downside, Lily. The problem with this is that it will not create a table. I can't use a table to solve for it. If I had to extend a table and said, all right, tell me what the value of x is when y is, or tell me the value of y when x is 15. Well, I could just call up my table and make predicted values, right? So y'all try to do that. Call up your table. So go to Control T. There's no function available. It only creates a table, okay, for functions. If you enter it as a relation, it will not create a table of values. So I can't solve this using a table. You understand? I can't find predicted values using the table. That's the downside of it. So the good side of it is I can still come up with a table if I put this in slope-intercept form, and that is a function, f1 of x, and this would be f2 of x in my calculator. Do you understand what I just said? So the good thing is this graphs anything. The bad thing is I don't have a table for it. Okay. So now that we know how to use our calculator, what are the problems going to look like on the EOC? We'll finish with problem 2 today, and then I'll give you the rest of the time to do your homework. So we're going to write a system of equations. This is what the EOC would look like. You'll probably have 2 questions like what we've covered so far, but now it's application problems. Okay, you got to be able to write in a system of equations by yourself. So it's going to give you a situation. It's a big word problem test is what it is, and you've got to solve it using any method that you want. So it's a biology question. Scientists studied the weights of 2 alligators over a 12-month period. Use the tables below to determine the initial weight and growth rate for alligator 1 and alligator 2. And then, after you find a function rule for alligator 1 and alligator 2's growth rate, I want you to figure out how many months did it take for the alligators to weigh the same amount. When are they the same? What x and what y do they both share? How do I do this? Right? I've got to come up with an equation for alligator 1 an equation for alligator 2 and find where they cross. If I can find where they cross, I found the solution. The value of x, which is the number of months, and the weight where alligator 1 is exactly the same as alligator 2. You follow that? So how do I do it? What would my system of equations be? Here's the part that you got to do on the EOC. And there's about 4 of those. Okay, and they're all word problems. Right? And the other 2 of the EOC questions are just going to be like what we've already looked at. So can y'all come up with an equation for the weight of alligator 1 depending upon how many months old it is? The weight of the alligator, right, my output, is dependent upon how old it is. So it's equal to what? How fast is that alligator growing? What is the slope? What's the rate of change? It's going up. It even tells you by 1.5, 1.5, 1.5 as my months are increasing by 1. So what is my slope? 1.5. It's my rate of change. Change in y for change in x, right? That's the last chapter. That's also chapter 2. Right? So what was the initial weight or the b value, which is known as my y-intercept? Remember, your y-intercept was where x is equal to 0. If x is 0, what is y? 4. So that means that you began, when this alligator was first born, it weighed 4 pounds. If you think of it that way. So the weight is the rate at which it's growing, which is 1.5 times the number of months, plus the initial weight when you first began recording how big that alligator was. You got it? So that's for what alligator? That's for alligator 1. What is a function rule for the weight of alligator 2? Same thing, right? The weight of alligator 2 is depending upon its months, but what's the rate of change? It's going up by 1 for each month. 1 pound for the second month, 1 pound for the third month, and so forth and so on. So what's the slope of this one? 1. What's my y-intercept of this one? Where did this one begin? When x was 0. When x is 0, what is y? 6. This began when this alligator was 6 pounds. And it's growing at a rate of 1 pound per month plus its initial weight of 6 pounds. Now, if I'm going to use a graph to solve this, the problem is I don't have an M and a W coordinate plane. See, this is my x-axis, this is my y-axis, so if I'm going to graph these, I can't leave this as weight in M. I need to rewrite it in terms of what? X and y. So my x is the what? Months. My y is the weight. The weight depends upon the number of months. That's the dependent variable, that's the independent variable. So really, my system of equations would be y is equal to 1.5x plus 4. And what would this one be? The weight of alligator 2 is what? X is the months, so this would be an x, and the weight would be y. So y is equal to 1x, which is just x plus 6. Now let's do this with pencil and paper. Right, so here's a problem. You're going to see a problem, right? Here's the problem with doing it pencil and paper. What's my y-intercept? 6. It crosses the y-axis for this first one right here. This one here, it crosses at 6. 1, 2, 3, 4, 5, 6. What's my slope? 1. So it rises up, run 1, like that. It's going to go forever that way and forever down. So if I connect that with a line, it looks something like this. You get the idea? Graph the second one. The y-intercept here is a 4, so it started off at 1, 2, 3, 4 pounds, and then it's growing at a rate of 1.5 per 1. Right? So if I go up 1.5 per 1. 1.5 per 1. Where is this going to cross? See, it crosses somewhere outside of my graph that I gave you. So it's going to cross something like there. Right there. Where is that point? Right? I can't see that here. I can guess. Maybe it's 1, 2, 3, 4 maybe, or 3.5. I don't know. How do I figure that out? If it goes outside of my graph, I could do a different scale and regraph it, or couldn't I just plug it in my calculator? All right, so let's go to our home screen. New document. Don't save my last one. When I add this graph, do I want to graph this in function notation or should I graph it as a relation? Y'all tell me. What would y'all do? I would do it in function notation because I have a table associated with it because this is in what form? Slope intercept. Slope intercept. If you're ever given, and y'all listen to this, if this is ever in slope intercept form, this is ever in slope intercept form, it's by far faster and easier and more beneficial to do it in function notation because I get tables back. Do you understand what I said? Okay, so I want you to do this one as function notation, not the relation. That's the downside. If it's not in slope intercept form, do it as a relation. If it's in slope intercept form, do it as a function. Did y'all hear me? So this would be y, or f of x, is equal to 1.5 what? X plus 4. Now I have tables for this, right? And then do my other one, which is y is equal to. So to graph another function, I hit tab, and I'm going to leave it in function notation because it will do tables. This would be x plus what? 6. And see where they cross. See, that's the same problem. I don't see where they cross. It's crossing outside of my screen just like this one crossed outside of my table. But guess what? I can zoom out and see that. Do y'all know how to zoom out? Go to menu. So hit menu. Go to Windows Zoom. And we're going to zoom out, which is 4. I want to zoom out over here somewhere. Boom. Now I see the intersection. Y'all know your calculator will not tell you the intersection unless you see it. So you have to see it. And then to find the intersection, I'm going to go to Menu, Graph Edit Entry. Right or wrong? I'm going to go to Menu and then do what? If I want to see the intersection, I go to Menu, then I go to Analyze Graph. Find the intersection, and I move it to the left and to the right of the intersection. So where do they cross? Now, is that my answer, and can I just move on? Can I just say 410? No. What does this mean in the real world? This is x, this is y. What did x mean is it related to this problem? That's time in months. What was y? The weight in what? Pounds. So you got to put that in words. Your answer will be in words here. In 4 months, both what? Alligators will weigh what? 10 pounds. Now listen. Sit down. Okay? Which one weighs less prior to 4 months? The red alligator, which is alligator 1. After 4 months, which alligator is going to weigh more? Which alligator is going to weigh more? The one that's growing out of alligator 1 is going to weigh more after 4 months. Do you see why? Explain to me why then. The growth rate is faster per month. Now that's going to be important for your homework tomorrow. Now we're going to stop here for today. Did the bell ring?